Hello guys, this is another lesson about molecular and ionic compounds. So first we can go through these two examples. This is essentially a review of the lessons about isotopes, Rutherford, and ions. But let's just review to understand the basics. So magnesium here, it's ion. What can I do? There's two that to become an ion, an atom has to be charged and it has to be sort of stable. So what does stable mean? Well, there's two things can happen. Either it gains or loses E in order to get an octet. Octet meaning a outer shell with 8 valence shell electrons. And another condition for stability, another possible condition, is that it also gains or loses. So gains in order to get a full first energy level with 2 valence shell electrons. Okay? And what I mean is that, for example, look at this fluorine, right? The first shell is full because it can only contain 2. So theoretically, if fluorine lost all these electrons and it ends up with these 2 here, then yes, it will be stable because it's a full shell. The first shell only contains 2 valence shell electrons, so it is stable. And for example, if fluorine gained an electron, it will have 8 valence shell electrons not on the first shell, on the second shell, on the second orbital. So hence it will also be stable. Okay, so there's 2 different types of stability depending on the atom. So some atoms have more orbitals, and hence you can go through the octet. That's a condition of stability. Some of them you only have one, a few, 1 or 2 orbitals, and there you have to, for stability, you can also sometimes it will be you end up with 2 valence shell electrons, but that'll be only in the first shell. Okay, so let's dive in. I'll move this to another area. Okay, so magnesium here, as you guys remember from your ions lesson, it will be much more energetically favorable for magnesium to just lose these 2 valence shell electrons, right? These 2 valence shell electrons to gain an octet. The octet is valence shell number is your shell number 2. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So it will end up with 8 valence shell electrons if you lose these 2. Instead of just gaining, it will be more favorable for magnesium to lose these 2 than to gain 6. So let's say it gains 6 here. 1, 2, 3, 4, 5, 6. Say it gains 6 there. Then it would be much more work to obtain the same result. To obtain the same result of 8 valence shell electrons, right? So magnesium would just lose 2 electrons, which gives it a charge of 2 plus positive 2. Okay. Fluorine, on the other hand, has 1, 2, 3, 4, 5, 6, 7 valence shell electrons. So it would be more favorable for it to just gain 1 more, rather than just lose 7 and then end up with these 2, which is also a full shell. So it's the same condition, but fluorine, it's much easier to just gain 1 more to gain a full shell, right? So it will gain 1 electron, which gives it a -1 charge. Okay, so what differentiates between these two examples? What is the difference? Well, the difference is simply fluorine is a, let me just label it. Fluorine is a nonmetal, and magnesium is a metal. Okay, that's the main difference. And from here, we can come to a conclusion that nonmetals actually gain electrons and have a negative charge, and metals lose electrons and gain a positive charge. Okay, that is the essential thing you want to know. Now, we'll just learn how to differentiate between a metal and nonmetal in your periodic table. So first thing I want to dive in is to just split these into nonmetal and metal categories. Draw a line to separate after number 2, group 2, and after group 13. Okay, and the ones from group 1 to 12 here, they're transition metals, so don't worry about them. They're not tested in the grade 9 curriculum. Okay, these transition metals, they're not really like talked about much, okay, in your grade 9 year. What you have to know is that the groups on the right here, they're nonmetals. And nonmetals, they tend to, as we said earlier, gain electrons. And metals are on this side, and they tend to lose electrons. Okay, and that's very important, because when you're asked to find, let's say, the charge of calcium, what's happened? What the hell happened? Okay, for example, I'm gonna find the charge of calcium. We have to first investigate what group it's in. A group is essentially just the vertical column in a periodic table. Okay, group tells you what number of the charge it is. So, and the number of but more importantly, the number of valence shell electrons. So B has 2 valence shell electrons because it's in group 2, and we know that it loses electrons. Hence, these 2 be lost, hence turning it into Be 2+. Okay, so we can apply that logic to all of these. So you want to find, like, oh, calcium is in group 2 and loses electrons, therefore calcium 2+. Okay, it's that easy. Okay, or like, oh, sodium is in group 1 and it loses, so Na+. Okay, so that's essentially it. So it tells you just how much valence shell electrons it is, and you say that, oh, it loses, so we have a positive charge. This side, it's nonmetals. So, for example, same logic. Pick a group. Pick a, like, whatever element you want to do. Say you want hydrogen. Okay, it's in group 15. 15 does not mean it has 15 valence shell electrons. You basically, for these numbers, when you have more than 10, just ignore the 1. Like, just ignore the 1. Just erase that 1. Okay, so now we have 5 actually. So nitrogen has actually 5 valence shell electrons, not 15. Okay, it's just in group 15, so it's easier to count, but just ignore the 1. So it's 5 valence shell electrons. 1, 2, 3, 4, 5. Okay, and we know that nonmetals actually gain electrons. So gain 3 more, right? Because it has 5, so it has to gain 3 more to get 8. So that gets you 3 minus. Okay. Same logic here. Sulfur. It gains electrons, right? And it's in group 16, meaning it has 6 valence shell electrons. 6 it has to gain to get a full octet. How much more does it have to gain? It has to gain 2 more to get 8, because it has 6 already. So that will give you 2 minus. And even oxygen has the same. Like, if you know the charge of one member of the group, it's the same charge for everything else. Okay, sulfur and oxygen have the same charge, or like polonium, they have the same charge because they're the same group. That's Now we move into what are ionic compounds and what are molecular compounds and what do they do. Well, ionic compounds are between a metal and a non-metal, and they transfer electrons. What does it mean? Well, and why does it happen? Well, a metal, as we said earlier, the characteristic is that it loses electrons, and non-metals has a characteristic that it gains electrons. It's like a donation center, right? There's a person needs you to donate, and you have the money, so just donate so it benefits both sides, right? Same thing here. This one wants to lose, this one wants to gain. And this simply just the one that wants to lose just transfers electrons to the one that wants to gain. So the metal gives electrons to the non-metal, and hence both sides benefit because they both have a full shell or octet. That's why I said it's very important to understand these basics first before we go into this one. Okay, molecular compounds, they share electrons between two non-metals, right? They share electrons, and why they share? Because non-metals, I'm saying NM here, they want to gain, and 2NM means they both want to gain. And to satisfy the condition, they will both have to share electrons. I'll explain and elaborate on that later. Okay. Let's dive into first ionic compounds because they're much easier. How to write their formulas and how to draw them. Okay. So first of all, let's say you want to find an ionic bond between lithium and fluorine. So lithium and fluorine. Okay. How do we find an ionic compound for that? Well, lithium will have a charge of, let's move up periodic table, lithium is in group 1. Group 1 means that it obviously loses electrons, so it will lose 1 electron, so it will have a positive charge of 1. And fluorine is in group 17, so like ignore the 1, meaning it has 7 valence shell electrons, and it gains, so it will have a negative charge of 1. Crisscross means that you sort of the charge goes as a subscript of the other atom, like basically. So let's say lithium and fluorine, right? Let's just write down the elements first. And this is 1, imagine there's a 1, invisible 1 here. So 1, 1, because the charge from fluorine is now a subscript of lithium, and the charge of lithium is now a subscript of fluorine, okay? This is a bad example. Let's try another example, okay? Let's try like magnesium and like fluorine. Magnesium has, let's go up. Magnesium is in group 2, and it loses electrons, meaning it will have a positive 2 charge. Fluorine, negative, as said earlier, negative 1. Okay, crisscross, same idea here. Magnesium here, the subscript of magnesium will be the charge of fluorine, which will be 1. You don't write the 1 here. And the subscript of fluorine would be the charge of magnesium, which would be 2. That will be how you write the formulas. Okay. And why it works is that because magnesium has 2, and it wants to lose 2, but fluorine can only take 1, right? Because it has 7. And magnesium has 2. So like even though magnesium wants to lose these 2, fluorine can only take 1. So what can happen is that there's 2 fluorines now. What if there's 2 fluorines? Then this one can go here, this one can go here. So it's to accommodate the transfer of electrons, so that no electrons are floating around. They're all transferred. There's no electrons that are not transferred. They're all transferred completely. That's why we add another fluorine here. and we see that there's 2 fluorines, and boom, 2. That's correct. And 1 magnesium here, correct. Okay, that's why it works. Okay, now I want to go to naming. Naming, you essentially, first step is that you will naming. Here, you will write the name of the metal. So let's say you have magnesium and fluorine. Okay, you will write the name of the metal, which is magnesium. So let's say you have magnesium, fluorine. So magnesium and fluorine. So we write the first thing, right? Is your name of the metal. Okay, and then you write the non-metal name, fluorine. Okay, and then you add the suffix IDE. Basically, fluorine, right? Ignore the INE and change it to IDE. Fluoride. Okay, so now your final compound is called magnesium fluoride. Another example. Let's say like I've been using fluoride a lot. So let's try another atom. Let's try like sulfur. Let's try like aluminum and sulfur. Write the name of the metal first thing. That's the first step. And then you write your name of the non-metal, and then you add your suffix. So basically remove the UR and add the IDE. Okay, aluminum sulfide. So there's no like when I say like add the suffix, there's no like specific rule for what you remove. Like you have to like sort of go through so many examples and like practice so much to the point like for example, fluorine instead of fluoride. Like as long as you have the IDE and like you sort of know like what sounds right. Like if you watch a movie, you hear you hear people say like sulfide, right? Not like sulfuride. So you know like what it's supposed to sound like, and you can remove your suffixes and remove stuff and add the suffix accordingly. And when you do when you do so many practice problems, I assure you, you will get it. Okay. So the naming part is a bit more tricky, but it's still pretty easy. How to draw? Okay, drawing. I sort of did it here. Like basically, you just draw your For example, you have the compound lithium fluoride. Lithium has one. You should basically just draw the Lewis dot diagrams and draw the electron transfer. Okay, like for example, you have lithium fluoride, and you draw the compound lithium. You draw the element lithium first with your Lewis dot, which has 1 VC, and fluorine has 7 valence shell electrons, so you just draw 7 valence shell electrons there as a Lewis dot, and you draw the 1 lithium transferring to the fluorine, the electron transferring. That's all you gotta draw. Okay. Same thing here. That's all you gotta draw. And like how you first start to draw is like basically let's say you have you want to draw calcium sulfide. Okay. Calcium has a charge. You first want to just like I would first approach it by naming like formula, like get the formula, and then I can draw it easier because I know like how much of each element to draw. Okay, so calcium has a charge of 2, and sulfur has a charge of 2 minus here, 2 plus and 2 minus. As you can see above here, calcium is a metal, meaning it loses electrons, and sulfur is a non-metal, meaning it gains electrons. Okay. So crisscross method, subscript of Ca will be the charge of sulfur and vice versa. Okay, but you'll end up with 2 and 2. This is something that I want to point out for the crisscross method. Although it's really easy, you might sometimes end up with fractions, like with numbers, the subscripts as 2 and 2 or like 2 and 4. And you can just reduce it to 1 and 1. Like whenever you can reduce, just reduce it. Okay, because that's the right answer. And then now we know that we only need one calcium and one sulfur to draw. So calcium, one calcium and one sulfur. So calcium has 2, sulfur has 6. Okay, draw your transfer and then boom, you're done. Okay, now let's move on to molecular bonding. So molecular bonding is when the electrons are shared, and through that sharing, both of them will gain electrons. So how does that work? Because we have to draw it first and see. So carbon, oxygen, first step is very similar to like drawing ions, like ionic compounds, is that you first just name the charges. Charge of carbon is a special one because it has 4 valence shell electrons, so it can either gain or lose. I'm assuming it gains. Oxygen also gains with 2, gains 2, and here crisscross method. Again, I said earlier, like this, it ends up with this like reduced, like this sort of 2 subscripts that can be reduced. So it reduces to this CO2. Okay, once we get that formula, you crisscross method. You like, first of all, start off same thing as ionic compounds. Okay, but then how to draw is that C, that C has, draw a Lewis dot for C. So C is 4 and O has 6. But because we already know the formula, which is CO2, we know that there's 2 oxygens. So let's draw another one. Okay, and here, actually, let me just draw it on the other side. It's much easier. So 1, 2, 3, 4, 5, 6. Okay, and how do you show the sharing? You just essentially you either can just connect it like this, or you can draw a bubble. Like draw a bubble like that. There you go. That's your CO2 right there. Okay, so easy. Just first get the formula, and then you use that to draw your Lewis dots, and then you're either, like for both of them, for both ionic and molecular, is very simple. Get the formula first, and then you just draw based off that, and then you draw either the transfer or the sharing based off that. Alright. As I said earlier, the formula is pretty much the same thing. Like you know how like we said that the ionic one, we do the crisscross method because you need, like for example here, 2 fluorines, you need to accommodate the electron transfer. For this one, for molecular compounds, it's just a trick. Like there's no explanation about it. Like for ionic compounds, the explanation is valid. For this one, it also somehow works, but like there's no like sort of explanation for it. Like it just works. Okay, so that trick is just write the charges, like crisscross method, same thing as ionic compound, how to write the formula. Okay, so let's draw some examples. Oxygen, carbon, we already did that. So let's try like something. Let's try nitrogen and oxygen. Okay, so you want to get the draw, name, and write the formula. First thing to do, formula. Nitrogen charge of 3 minus, oxygen 2 minus. Refer to a periodic table when you do this. I just memorized it because I did too much practice already on this topic last year. So there we go. If you want to refer to the table, it's here. Nitrogen is in group 15, meaning it will gain 3, and oxygen is in group 16, meaning it will gain 2. Crisscross method down here. There's your formula. You don't have to name. Mistake here. You don't have to name molecular compounds if you're not just yet. Okay. And then you want to get the drawing. So nitrogen, 5 valence shell electrons. Oxygen, 6 valence shell electrons. want to get 2 nitrogens. Okay, it's gonna be hard. You want to get 2 nitrogens. And 3 oxygens, okay. Okay, that's pretty tough. Start over here. Like the way you draw doesn't really matter, but I want to just do it in a way that like is the best for me. It's the easiest for me to draw. So you have 6 here, and then another 6 down here. Showing another 6 down here. Okay, got 6 there. So let's draw the bonds. Boom, boom. That's 1 bond. Get one here. Get another one here. Another one. Okay, this is gonna be okay. My drawing is really bad. Okay, that's not good at all. Okay, let's just redo that real quick. There we go. That should be a bit easier. There. That's your N2O3, nitrogen and oxygen. Okay, magnesium and sulfur. So pretty easy. First is to get the formula. So magnesium has 2 charge of 2 minus, 2 plus actually. Sulfur has charge of 2 minus. Crisscross method, and with this, reduce that to MgS. That's your formula. Okay. Naming. Write the metal first, and then you write your non-metal, but you have the IDE suffix. Okay. That is your name. Now, final step is to just draw it. You want 1 Mg, 1 S. Okay. S has 6. Mg has 2. Transfer it. There we go. If you guys have any questions, feel free to message us on Discord or email us.